Good day, I'm Dr. T and welcome to my office. Today I'd like to talk about oxygen-bearing functional groups, and I'm not going to cover all of them because there's a lot. Oxygen is an incredibly useful and versatile atom, and you will see it a lot in organic molecules. Okay, so the simplest oxygen functional groups are going to be the alcohol and the ether. For an alcohol, you have a hydrogen. It has been replaced with an oxygen, and a hydrogen has been attached to the other end of the oxygen, thus creating an OH group or an alcohol group. Alcohols are polar, so enough of them and you can take what would normally be a greasy hydrophobic molecule and make it hydrophilic. Obviously enough depends on how big your molecule is to start with. So for small molecules with only a couple of carbons, simply one alcohol group will make it miscible in water, whereas other molecules, one alcohol group is not nearly enough. Ethers, on the other hand, the oxygen is found between two carbons. So you go carbon, oxygen, carbon. And in this case, you don't gain the same interactions with water because you cannot do hydrogen bonding. At least you don't have the hydrogen part of the hydrogen bonding. So as such, these do not drastically increase the boiling point as the alcohols do. But they do make a molecule that is somewhat more polar than what it would otherwise be. Now, with the alcohols, those of course increase chemical reactivity, give a nice point to react with, and typically for biological systems, they're going to want to react with an organic molecule on a carbon where an oxygen is present, whether it be in the form of an alcohol or some other functional group. Speaking of some other functional groups, a double bond to oxygen. So a carbon double bonded to an oxygen is known as a carbonyl, and there are two types of functional groups that are a carbonyl and nothing else interesting going on. There's actually a lot of functional groups that are a carbonyl and other features. So the two that I'm describing are the ketone and the aldehyde. A ketone is a carbonyl that the other two bonds, because remember, carbon forms 4 bonds, a double bond to an oxygen is going to be 2 of them, and we have 2 bonds left over. If both of those other 2 bonds are carbons, that is a ketone. If one of those, or in theory both, but there's only one molecule in that case, are hydrogen, then that is an aldehyde. So if you have a hydrogen attached to a carbonyl, you have an aldehyde. If it is simply carbons attached to the carbonyl, it is a ketone. Once again, these are both functional groups that biological systems like to react with. I should point out, though, that aldehydes are particularly reactive. That carbonyl creates a nice point for chemical reactions to take place, and the presence of the hydrogen there provides very limited steric hindrance. Steric hindrance is simply atoms getting in the way of the reaction, just physically blocking them. Because hydrogens are so small, it provides very little interference with that, making aldehydes particularly reactive. This is actually why diabetes is a thing. Glucose contains an aldehyde, and that aldehyde is unfortunately able to randomly react with various biological molecules, thus causing damage to those. But if you've got too much glucose floating around in your bloodstream, you're getting too much damage, and your body won't be able to repair all the damage, and thus the negative consequences of diabetes ensue. So, yeah, not good, but an unfortunate fact of life. Now, before I leave oxygen, I actually want to jump down to oxygen's group member, that of sulfur. If you have an alcohol, but instead of using an oxygen, you use a sulfur, because remember, atoms in the same group will have similar chemistry, you get a thiol. Thiols are noted for smelling like rotten eggs. They have a particularly unpleasant smell. They are used in biological systems, specifically the amino acid cysteine is a thiol and absolutely important for protein function. Generally speaking, though, thiols get a lot less press within the organic chemistry community than the alcohols. Alcohols are definitely one of the stars. One last point about alcohols. The carbon which the alcohol is bonded to actually does make a difference as to the chemical reactivity of the particular alcohol. If the alcohol is attached to a carbon and that carbon is attached to only one other carbon, so essentially this is at the end of a molecule, then we call that a primary alcohol. If that carbon is attached to two other carbons, effectively it's in the middle of the molecule, we call that a secondary alcohol. Those typically are a little bit less reactive. If the carbon to which the oxygen is attached to three other carbons, so it does not have hydrogens on it, then we call that a tertiary alcohol. And these are typically not very reactive, if not downright inert in many chemical reactions. So with that said, have a wonderful day.